Okay, so hello everybody. Today we're going to be doing another walkthrough of an A-level maths paper. This is the 2025 A-level maths paper 2, pure 2, but it's not the standard version, it's the modified version. So just some backstory, in the most recent examinations, for some reason people with axis arrangements, in particular those who had to get bigger papers, the ones that are magnified, they had different papers for some reason. I don't know exactly why that was the case, and while everyone, 99% of the people did sit the normal exam, which I've done on the channel, 100-ish people sat this paper, which is the modified version, and it's a completely different paper. And yeah, let's get into it. So you can get this paper in the description, and it's also good practice as well if you do this paper, because it's completely blind solved. I'm going to go through it. Okay, so question 1 says, figure 1 shows a sketch of the graph with the equation y is equals to mod x minus 4 plus 10. The point P shown in figure 1 is the vertex of the graph. State the coordinates of P. So, for these types of questions, what I like to do is I want to find the equation of this line, and I want to find the equation of this line, and I just want to equate them, and that'll give me my value of P. It's a pretty difficult question to start off, to be fair. So, in this case, it's mod x minus 4 plus 10. And how I would find those equations is I would just keep it as it is. So one of my equations would just be x minus 4 plus 10 to give me x plus 6. And my second equation would just be the negated version. So I would add a minus outside the modulus and treat them as brackets. So that would be minus x plus 4 plus 10 to give me minus x plus 14. Now I just equate them. So x plus 6 is equals to minus x plus 14. So 2x is equals to 14 minus 6, which is 8. So x is equals to 4. And now just sub in the 4. So I know that one of them was y is equals x plus 6. So I'm just going to say y is equals to 4 plus 6. So it's going to be 4, 10, which is my coordinates of P. Part B says use algebra to solve the mod of x minus 4 plus 10 is equals to 3x. And it says solutions relying on calculator technology are not acceptable. But you do definitely, if you have a CG50, do use it. It's so easy. You just plot this in your graph sketcher, you put 3x, and you can check your marks. I think in an A-level maths paper, you should be able to check at least 90% of your marks. And I'll go ahead and show where we can check them, for example. But in this case, it's 3x. You would know that the line 3x would be something like this. It would intersect somewhere here, and it would not intersect the positive part. So therefore, I would just put the negative part, like I mentioned before, how I split the line. So if it's modulus of x minus 4 plus 10 is equals to 3x, I would use the minus one. So minus x plus 4 plus 10 is equals to 3x. And I would get minus x is equals to 14. Oh, wait, no, sorry. Minus x plus 14 is equals to 14 is equals to 4x, so x is therefore 7 over 2. And that's my answer for question 1. Question 2a says sketch the curve with equation y is equals to 2 to the power minus 3x, stating the coordinates of any point of intersection with the coordinate axis. So let's go for it. I'm just going to do a rough sketch, y-axis, x-axis. So any sort of graph where you have a to the minus x looks like this. This is the form, and there's an asymptote at y is equals to 0 towards 0. So make sure you sort of show that it doesn't reach the x-axis, but you also have to show that it doesn't get parallel. So there must be a slight bend to it. And the next thing they wanted us to show any points of intersection with the axis. So when x is equals to 0, y is equals to 2 to the minus 3 times 0. 2 to the 0 is just 1. So this would be 0, 1. So that's my sketch. B says by writing 1 over 32 root 2 as a power of 2, solve the equation which is given. Okay, so 2 to the minus 3x is equals to 1 over 32, which is the same as saying 2 to the power of 2, 4, 8, 6, 2 to the power of 5 times root 2, which is 2 to the power of a half. So 2 to the minus 3x is equals to 2 to the power minus 5 times 2 to the power of half. 2 to the power of minus 3x is equals to 2 to the power of minus 10 over 2 plus a half would be minus 9 over 2. So minus 3x is equals to minus 9 over 2. 3x is equals to 9 over 2. 6x is equals to 9. X is equals to 3 over 2. So that's my answer for 2b. Let's get on to the next question now. Question 3. A sequence of terms a1, a2, a3 is defined by a1 equaling 4 and an plus 1 equal to kan plus 3, where k is a constant. Given that the sum from 1 to 3 is equals to 12, all terms of the sequence are different, find the value of k. Okay, so I know a1 is equals to 4, so I can say that a1 is equals to 4, so I can say that a2 is equals to k a1 plus 3. I know a1 is 4, so a2 is equals to 4k plus 3. That's my first step. Then I can say that a3 is equals to k a2 plus 3. So I can say that a3 is equals to k times 4k plus 3 plus 3. So therefore, then I can say that a1 plus a2 plus a3 is equals to 12, as it shows me here. So a1 was 4, a2 is 4k plus 3, and a3 is 4k squared plus 3k plus 3, which should equal 12. Let's solve. 4k squared, these are k, so these would be plus 7k, and it would be 3 plus 3 plus 4, which would be 610 plus 10 minus 12 equals 0. So 4k squared plus 7k minus 2 equals to 0. Now, already I can see that this piece of information will prove valuable, I think, because it says all of the terms of the sequence are different. So I assume there'll be two values of k. One value of k will be such that the terms are the same, and one would be that it gives us a different term. So I would have to check which one does that, I think, at least. So 4k squared plus, I'm going to split the middle term, 8k minus k, minus 2 is equals to 0. 4k, k plus 2 minus 1, k plus 2 is equals to 0. So k is equals to minus 2 and k is equals to 1 over 4. Now let's test. So I know a1 is equal. Now first I'm going to test where k is minus 2. So a1 is 4. If a1 is 4, a2 is 4k plus 3. So if 4k plus 3, so that would be minus 8 plus 3, which would be minus 5. And then a3 would just be minus 2 times minus 8 plus 3 plus 3. So this would be minus 2 times minus 5 plus 3. So that would become 10 plus 3, which is 13. So therefore, when k is minus 2, it produces 3 distinct values of a. So therefore, my answer for 3 is that the value of k is minus 2. And I'm not going to bother checking 1 over 4 because it's most likely incorrect. It is incorrect because k is minus 2 has given us 3 distinct values. So that's the answer for question number 3. Let's get on to question number 4 now. Question 4 says figure 2 shows a sketch of the curve with equation y is equals to f of x, where f of x is equals to 2 to the power of x minus 10x. The curve crosses the x-axis as x is equals to alpha, and when alpha is greater than 1, as shown in figure 2. Show that alpha lies in that interval. So you should know by now these are very standard questions. So you have your f of x to be 2 to the power of x minus 10x, and you want to show that alpha lies in the interval. So you would do f of 5, and you would do 2 to the power of 5 minus 10 to the power 10 times 5, which is minus 18, and then you would do f to the power of 6, f of 6, which would be 2 to the power of 6 minus 10 times 6, which would be plus 4. And then you basically say that there's a change of sign, and since the function is continuous, there must lie a root. There must be a root. So make sure you really get those two key points, that the function is continuous and there's a change of sign. So that's the answer for part A. Part B says, given that the first derivative of this function is equal to p times 2 to the x minus 10, you have to find the value of this constant p. Okay, so you should know by now. Let's take the function. This is 2 to the power of x minus, actually you might not know this, depends on when you are in your prep really. 2 to the power of x, what was it? Minus 10x is equals to your f of x. And you just want to differentiate this, right? All it is asking you is to differentiate. Now, a to the power of x, when differentiated, is essentially a to the power of x ln a. I'm not going to go through the proof now. If you want to go to the proof, you can search it up. But in this case, we would just write that down. It would be 2 to the power of x ln 2 minus, and then essentially your 10x would just become minus 10. So it would be 2 to the power of x ln 2 minus 10. And it says p times 2 to the power of x minus 10 is that. So your p in this case is ln 2. That's part B. Taking x to the power x as your first approximation equals to 6, apply the Newton-Raphson method once to obtain a second approximation to alpha. Show your method and give your answer to 3 significant figures. Okay, I don't actually have the formula book open, so let me just open it up. Okay, so this is in the formula booklet, and what it says is that the Newton-Raphson method states that xn plus 1 is equals to x to the n minus f dash x of n divided by f dash xn. Like that, like so. So essentially, it's asking us, and what's the question asking us? Taking x to the 0 is equals to 6, and we have to apply it once to f of x to obtain a second approximation to alpha. Okay, so we only need to apply it once. So therefore, we need x1, which would be x0 minus fx0 over f dash x0. And we know x0 to equal 6. So therefore, it would be x to the 1 is equals to 6 minus f of 6. And f of 6 we calculated to be 4 minus 4 over, and now we would just do f of 4 over here. So f of 6, sorry, we would do over here, which would be 2 to the power of 6 ln 2. 2 to the power of 6 is going to be 64. So this would be 64 ln 2 minus 10. So therefore, this would be 64 ln 2 minus 10. And this approximately equals to, does it say to leave it to 3 significant figures? So this would be 5.88. And that's my answer for part C. Part D says the curve has a minimum turning point at Q. Use the answer to part B to find the x coordinate of Q, showing your working and giving your answer to 3SF. Okay. Now, essentially, whenever you see minimum turning point, if you see maximum or anything like a tangent, obviously it's pointing towards differentiating. But in cases of minimum and maximum, you want to differentiate and equate it to 0 as well. So it gives you a hint to use your answer in part B, as part B already gives us the differentiated form. And we worked out that it was going to be 2x ln 2 minus 10 as f of x. F dash of x, sorry. So therefore, we equate this to 0 and say 2x ln 2 is equals to 10. So therefore, I could say 2x is equals to 10 divided by ln 2. I could apply another ln, so I could say ln 2 to the power of x is equals to ln 10 of ln 2. And then I could say x ln 2 is equals to ln 10 over ln 2. And then I could say x, therefore, is ln 10 over ln 2 divided by ln 2. And then you just plug that function or that expression in your calculator and be careful. And just you get your answer to equal 3.85 to 3 significant figures. And that's my answer for part D. And that's question number 4. Okay, question 5 is on the trapezium rule. You will need your formula booklet if you don't have this formula memorized. Maybe you do, maybe you don't. I don't, so I have it open. So it says that the integral from b and a of y dx is equals to half h times y0 plus twice y1 plus y2 plus all the way to yn minus 1, yn minus 1 plus y to the n, end of bracket. Okay. Now, in this case, what do we have here? Now, essentially, what is your h? Your h is just the difference in x values. Now, if the number of strips are given, there's a different method to go about it. But in this case, my h is just 0.25 because the difference every time is 0.25. And then my y values, this would be my y0, y1, and this would be my last y value. So in this case, let's start solving. So the integral from 1.5 to 0 of e to the minus x squared would be a half times your height, which was 0.25, times y0, which is 1, plus 2 times y1, y2, y3, y4, and y5. So 0.9394, I'm just going to write it as a column, plus 0.7788, plus 0.5698, plus 0.3679, plus 0.2096, and close the bracket, and then, oh, sorry, not close the bracket, and then outside of the bracket, make sure you don't multiply this part by 2, because this is your yn, right? It's your last term. So plus 0.1054, and now you can close your bracket, and you can do this on your calculator to get the correct answer of it would be 0.855. That's my answer for number part A. Now we can do part B with the answer we have from part A. I like these questions. These are more interesting because it's all about integral and manipulations. So B part I essentially says that what's the integral from 1.5 and minus 1.5 of e to the minus x squared. And the data we have is that the integral from 1.5 and 0 of e to the minus x squared is 0.855. So in this case, it's essentially just multiplying this by 2, because you're essentially just doing the integral from 0 and minus 1.5 and then 0 and positive 1.5. So you're just doing 2 sets of that integral, but it's joined in 1. So therefore, you would just do 0.855 times 2 to give you the answer of 1.71. Now let's do part 2. Part 2 is just the integral of 1.5 and 0 of e to the minus x squared plus 7. So we can split this integral up. I can do 1.5 and 0 of e to the minus x squared plus the integral of 1.5 and 0 of 7. We know this already equals 0.855. 0.855, and then I can say this part would just be plus 7x, which is evaluated between 1.5 and 0, to give me an answer of 0.855 plus 10.5, that's not 10.5, which equals 11.355, and that's my answer for number 5. Question 6 is on binomial expansion, and it asks us to find the first 4 terms in ascending powers of x of that function. Now this is quite standard. There was an outrage as to why there wasn't a regular binomial expansion question in the previous paper, or sorry, in the non-modified papers, but there was one here. So that was a questionable decision from Edexcel, but we persist. So in these cases, the standard way is you just bring the 2 plus 3x up. So it would be 4 times 2 plus 3x to the power of minus 2. Now you want to isolate the x such that there's only a plus 1 added. So you would do that by taking out a 2. So you take out the 2 as usual, but there's a power to the minus 2. So you make sure you add that power on as well. And therefore you're left with 1 plus 3 over 2x times to the power minus 2. Now just quickly notice that 4 times 2 to the power minus 2 is just 4 times 1 over 2 squared, which is just 4 times 1 over 4, which would essentially just be 1. So this section over here is just 1. So therefore, you just need to focus on the expansion 1 plus 3 over 2x to the power of minus 2. Nice. Okay, let's keep on persisting now. The formula, let's write it out. It's 1 plus nx plus n times n minus 1 over 2 factorial x squared plus n times n minus 1, n minus 2 over 3 factorial x cubed. So those are my first 4 terms. So therefore, let's start filling it out. 1 plus, what's my n? It's minus 2. So minus 2. And what's my x? It's 3 over 2x. So it's 3 over 2x plus minus 2 times minus 3 over 2 times 3 over 2x squared plus minus 2 times minus 3 times minus 4 over 6 times 3 over 2x cubed. and do this full expansion, and we should get 1 minus 3x plus 27 over 4 x squared minus 27 over 2 x cubed. So make sure you're careful. And you should also notice that like there is a pattern to the signs. Either they're staying the same or they're alternating. In this case, they alternate. So yeah. Now for part B, it says find the range of values for which this expansion is valid. For all of these types of questions, you just want to ignore the power, ignore the everything. Your simplest version is 1 plus 3 over 2x to the power of minus 2. You ignore the power and all you say is that the modulus of just the x part, so the modulus of 3 over 2x is going to be less than 1. That's it. And now you want to just rearrange. You take the 3 over 2 to the other side. So you can say the modulus of x is less than, when you divide it, it would become 2 over 3. So that is my range of validity for 6. And that's question 6. Question 7, an interesting looking question. The functions f and g are defined by f of x is 3 over 2 ln x, g of x 4x plus 3 over 2x plus 1. Find gf of e squared, writing your answer in simplest form. Okay, let's go about it. Okay, so we have g of x to equal 4x plus 3 over 2x plus 1, and my f of x is 3 over 2 ln x. It's asking for g f of x, so therefore essentially you would input 3 over 2 ln x into these two x's. So therefore I'm going to write out my g f of x function, which would be 3 over 2 ln x plus 3 divided by 3 over 2 ln x plus 1. Now let's keep on going. 4 and 2 would cancel out to become 2. Times that by 3, it would become 6 ln x plus 3 over, these 2's would cancel out as well. So this would become 3 ln x plus 1. Nice, it becomes a sort of easier function. It says now we want to input e squared. So this is gf of x, and now I want to input gf of e squared. So 6 ln e squared plus 3 over 3 ln e squared plus 1. We know what log rules say. Ln e squared would essentially just be 2 ln e, and ln e is 1. So therefore 12 ln e would just be 12 plus 3 over 3 ln e. 2 would come to that side, so it would become 6 ln e, which is 6 plus 1. So this would become 15 over 7. Nice. So it solves quite nicely. And that should be the answer for part A. Part B says prove that g is a decreasing function. Now, in these cases, you always want to differentiate and you want to show that the derivative, since it's a decrease function, is less than 0. So let's do it. We know g of x is 4x plus 3 divided by, what is it, 2x plus 1? Yep. So therefore, g dash of x is, okay, wait, v is going to be 2x plus 1. V dash is 2, u is 4x plus 3. I always write these out to make it simpler for myself. And therefore, u dash is 4. We know that it's vu dash minus uv dash over v squared. So v is going to be 4 times 2x plus 1 minus 2 times 4x plus 3 all over 2x plus 1 squared. This would work out to be 8x plus 4 minus 8x minus 6. These cancel out, divided by 2x plus 1 squared. And therefore, I'm left with minus 2 over 2x plus 1 squared for my g dash of x. Now, how do I know this is a decreasing function? Essentially because, first of all, the range of validity is stated to be x is greater than 0 anyway. So for when x is greater than 0, this part will always be positive, and at the numerator we have a negative. So anytime we have, for example, a minus negative, or sorry, just a negative over a positive, right? This equals negative in all cases. So if I say minus 5 over 8, oh, actually, no, that's not a good example. Let's say minus 8 over positive 2. This simplifies out to be a negative number, and that's always the case, right? So in these types of examples, a negative over a positive is always negative. Therefore, for x is greater than 0, the derivative must be less than 0. So therefore, you can say that g dash of x is less than 0 when x is greater than 0. Therefore, g of x must be a decreasing function. Must be decreasing function. Okay, part C says find the range of the function fg. Okay, so let's do it. So I know f of x is equals to 3 over 2 ln x, and then I know g of x is equals to 4x plus 3 divided by 2x plus 1. Let me just double check that. Yeah, it is. And I know that I'm given a condition that x is greater than 0 for both cases. So you could join the functions. You can also do it such that you find g of x first and then input it. I'll make it simpler and I'll just join the function. So I'll just say fg of x is 3 over 2 ln 4x plus 3 divided by 2x plus 1. Now let's consider the behavior of this function. So x has to be greater than 0. However, if x does tend to 0, what do we get? We get 3 over 2 ln 4 times 0 is 0 plus 3 would be 3. 2 times 0 is 0 plus 2 times 0 is 0 plus 1 would just be 1. So we get 3 over 2 ln 3 when x approaches 0. How about if x approaches a very large number, let's say infinity? Then I would get 3 over 2 ln 4. Now, if I have 4x plus 3 over 2x plus 1, if x is so large, if it's like a million, these small constants won't make a difference, right? So essentially, you're just left with 4 over 2, or 4x divided by 2x, which is just 2. So therefore, when x is really, really large, you have 3 over 2 ln 2. And because I'm not using any negative values because it states in the condition that x is greater than 0. So now I know that when x approaches 0, or when x is very small, therefore it's 3 over 2 ln 3. But it does not reach this inequality. And as x keeps getting larger and larger and larger, it becomes closer and closer to 3 over 2 ln 2. But it does not reach it. Therefore, your inequality would be that 3 over 2 ln 2 is less than fg of x, which is less than 3 over 2 ln 3. It might seem a bit confusing as to why that's the case, because normally if it's approaching 0, you might say, oh, 0 is smaller than infinity, so you would use it the other way around. But in this case, because as the number of x is getting larger for the function fg of x, you're getting smaller, your value is getting smaller, right? So this is how you would frame your inequality. And you can always use your calculator. So now in your calculator, you can go on your CG50, sketch this function. If you have the CG50, that's very helpful as it sort of gives you an idea on how to go about it. But that's the answer for question number 7. Question 8 now. It says figure 3 shows a sketch of the part of the curve with this equation. Y is equal to root 2x minus 7. The region R, shown shaded in figure 3, is bounded by the curve, the x-axis, the y-axis, and the line with equation y is equals to 5. Find the exact area of R. So quick plan, how am I going to do that? I'm going to find this intersection point. That'll give me this x value. And therefore, I can find the area of the square. And then I can integrate from this point to give me this, let's call it region y. And then R essentially would just be the square minus y. So let's do this now. First step is give me this intersection point. So this is y is equals to 5. And my equation is root 2x minus 7. So y is equals to, root 2x minus 7 is equals to 5. Therefore, I'm going to square both sides. 2x minus 7 is equals to 25. 2x is equals to 32. X is equals to 16. So this point over here is going to be 16. So therefore the area of the, it's not a square, sorry, it's a rectangle. So area of the rectangle is just going to be 16 times 5, which is going to be 80. Okay, that's my first step done. Now it's time to integrate. So I need to integrate from this point, which is the point when y is equals to 0. Of the line root 2x minus 7. So when root 2x minus 7 is equals to 0, 2x minus 7 is equals to 0, 2x is equals to 7, x is equals to 7 over 2. So this point over here is going to be 7 over 2. Now I'm going to integrate this equation with the limits 16 and 7 over 2. So the integral between 16 and 7 over 2 of root 2x minus 7. So this is essentially saying 2x minus 7 to the power of half integrated between 16 and 7 over 2 dx. Now let's do the integral. So I would get 2x minus 7, add 1 to the power 3 over 2, divide by the new power, times by the differential of the inside, which would be 2. Everyone will have their own methods on how they go about solving this. Evaluated between 16 and 7 over 2. So that would just be 2x minus 7 to the power of 3 over 2 divided by 3, evaluated between 16 and 7 over 2. Therefore, this would be 2 times 16, which is just 32, minus 7. So 25 to the power of 3 over 2 divided by 3, minus, that would just be 0. 2 times 7 over 2 would be 7, minus 7 would be 0 over 3. So that would just be 0. So we just have 25 to the power of 3 over 2 over 3, which gives me an answer of 125 over 3. Therefore, this region over here is 125 over 3, and my square is, rectangle is 80. So I would just do 80 minus 125 over 3 to give me a final answer of 115 over 3. And there we go. That's my answer for question number 8. So 9a says, prove that a difference of the square of two consecutive odd numbers is always a multiple of 8. So I could say that 2n plus 1 is an odd number. You should know this, that any number n when multiplied by 2 is always even, and if you plus 1 to it or minus 1, that would make it odd. But I'll choose my first number to be 2n plus 1. Therefore, my consecutive odd number, the next odd number, would be 2n plus 3. So therefore, it says that the difference of the squares of two consecutive odd numbers is always a multiple of 8. So I'll start off and subtract the smaller number from the larger number. 2n plus 3 squared minus 2n plus 1 squared. Let's do it. 4n squared plus 2 times 2 times 3, which would be 12n times 3 squared plus 9. I think that's right. Yep. No, yeah, plus 9. Minus, this would be 4n squared plus 4n squared plus 2 times 2 times 1 would be plus 4n plus 1 squared. Now we just solve this. So 4n squared plus 12n plus 9 minus 4n squared minus 4n. Why is there still square there? Minus 1. These n squares cancelled out. We're left with 8n plus 8. So therefore, I can take out an 8 and say 8n plus 1. Therefore, and then you just repeat that statement. Therefore, the difference of, I'm not going to write the whole thing out, the difference of, and then you just write the entire thing. The difference of two consecutive odd numbers, the difference of the squares of two consecutive odd numbers is always a multiple of 8. It's always a multiple of 8. This is like your summary statement, multiple of 8. There we go. Now, part B is essentially a counterexample. You just need any sort of counterexample, which shows that the difference of the squares of two consecutive even numbers is not always a multiple of 8. So I could say, what can I say? Two consecutive even numbers. I'm just trying to think of an example in my head. If we take 4 squared minus, so if I say 2 and 4, these are two consecutive even numbers. I could say 4 squared minus 2 squared is 16 minus 4, which is 10. 10 is not a multiple of 8. So any suitable counterexample would work here. And that's my answer for question number 9. Okay, question 10 says figure 4 shows a sketch of the curve with equation y is equals to f of x, where f of x is this function, where k is a positive constant. Given that the curve has a maximum TP at x is equals to 1, show that k is equals to 2. Okay, so let's think. How are we going to do this? Maximum turning point. So the first thing, without thinking, I'm going to do is start differentiating. So part A, f of x is equals to 4x minus k times e to the minus x squared. An interesting function, e to the minus x squared. Okay. Now, how would I differentiate this? It's essentially two functions of x, so I can't just differentiate outright. I'll have to use the product rule. Product rule says that we have to do vu dash plus uv dash, and v and u can be anything. So I'll take v to be 4x minus k, and therefore v dash will be 4, because k is a constant. And then u will be e to the minus x squared, and u dash would essentially just be the derivative of the power times by e to the minus x squared, so it will just be minus 2x e to the minus x squared. Now let's do vu dash plus uv dash. So vu dash would be minus 2x e to the minus x squared times 4x minus k plus 4 e to the minus x squared, which would just be, that. Now, the second step is realizing that says maximum turning point at x is equals to 1. So essentially, when f dash of 1 occurs, this is equals to 0. So this is f dash of x, right? So therefore, I would do f dash of 1 and say that to start plugging in all of the different bits and pieces, for example, if we look at it, this would be x minus 2 e to the minus 1 squared times 4 minus k plus 4 e to the minus 1 would equal 0. So therefore, I would get minus 8 e to the minus 1 plus 2k e to the minus 1 plus 4e to the minus 1 is equals to 0. Now what can I do? I can do minus 8 plus 4 to give me minus 4e to the minus 1, and then I'll bring that to the other side as well. So I'll say 2k e to the minus 1 is equals to 4e to the minus 1. E to the minus 1s would cancel out. 2k is equals to 4. Therefore, k would be 2. And that's my answer for part number A. For part B, it says, hence show that the only other turning point is at x is equals to the minus half. So what I could do over here is, now I know the new k value, so let's pick it up back from this step. So I'll say part B. So f dash of x is equals to minus 2x e to the minus x squared times 4x minus k, which is now 2, which we calculated, 4x minus k plus 4e to the minus x squared. Okay, so what we could do is let's factorize out an e to the minus x squared from the entire expression. Actually, let's expand it, and then we'll do it to make it easier. So minus 8x squared e to the minus x squared plus 4x e to the minus x squared plus 4e to the minus x squared. So what's common in all terms? It's e to the minus x squared. So that would give us minus 8x squared plus 4x plus 4 is equals to 0, because this is the derivative, right? We're trying to find the other turning point. So therefore, now the next step is to, what does the question actually ask us? It says, show that the only other turning point, that is x is equals to the minus half. Okay, so essentially what we have to do is, we know that either e to the minus x squared would equal 0 or minus 8x squared plus 4x plus 4. Now a quick proof, minus e to the x squared is equals to 0. Let's ln e to the minus x squared is equals to ln 0. This is undefined, so therefore this cannot have any x solutions. Now this, on the other hand, when you go do and solve it in your calculator, which you don't have to do, you can just show that one of the values are x is equals to minus half, and I presume the other x value would be the one we calculated, which is at x is equals to 1. So you show that these are the only two values that can exist, and therefore that would be your answer. A bit of a long haul for 1 mark, but I don't think there's a different method to do this, but if there is, feel free to share. Okay, let's get on to part C now for this question. It says, given that the equation f of x is equals to p, where p is a constant, has exactly 2 distinct roots, find the range of possible values for p. So what it's exactly asking us is that there's some y value p, which would be a horizontal straight line, such that there's 2 distinct roots or 2 solutions. So what I can notice is that if I draw a line here, a bad line, but if I draw a line here, there's only 1 solution. If I draw a line at the bottom over here, again, there's only 1 solution. But the second I go above this line, I'll have 2 here and here. Again, 2 and 2, here, 2 here. And then the second I go below this line over here, I would have 2, and I would always have 2, because then you'd have this solution at that line. So essentially what you're saying is that, what this means is that you'll always have two solutions when your x value is greater than this turning point and less than this turning point. So I could just give the x values and say that it's greater than that and less than that, but it's asked for a value of p, and p is a y value, right? It's a horizontal line. So what I would do is I would sub in the x values for the turning points, which I have. X is equals to 1 and x is equals to minus half. Get those values of y, and then write the inequality like that. So let's start off. So I know that, for example, f of x is, for part C, sorry, f of x is equals to 4x minus 2 times e to the minus x squared. So I know my first x value for the turning point would be a minus half. So let's try that. F is to the power of minus half is equals to 4 times minus half is minus 2, minus 2 minus 2, minus 4. E to the minus, and you're doing a minus half squared. So that would be minus 4e. Minus half squared would be 1 over 4, but you still have that minus outside. So that would be minus 1 over 4. Now let's do the other side of the turning point, which is f of 1. 4 times 1 is 1. Minus 2 would be 2. E to the minus, and you're just doing 1 squared. So that would be 2e to the minus 1. So now I've written both of my inequalities. So I know this turning point is the minus 4e to the minus 1 over 4. This turning point would be the 2e to the minus 1. So therefore, my range of p would be such that p is greater than 4e to the minus 1 over 4, yet it's smaller than 2e to the minus 1. And does it have any other restrictions in the question? No, I don't think so. And you can also mention that, we did know from before that e to the minus x squared, it cannot be 0. So if you want, you can also write p does not equal 0. And that's my final answer for question number 10, is it? Yeah. Question 11 says that given that theta is measured in radians, prove from first principles that the derivative of sine theta is cos theta. A very standard question. You know, people hope that this comes up. It's a free 5 marks. You should definitely know this. These are the types of questions that are the very basics, because this can easily come up. And I think it can come up in the 2026 exams. This was in the the modified paper. So because this was in the modified and we didn't have any first principles in 2025, I'd say this is definitely something which can come up. If not sine x, maybe cos x or some other function. Okay, let's do it. So I'm given that h tends to 0. I'm given these two facts. I want to write my own facts as well. I also want to say that when sine a plus b, I get sine a cos b plus cos a sine b. Now I want to get to it. So first principle says that the derivative of f of x, which is sine x in this case, the derivative, first principles says that limit when h tends to 0 is f of x plus h minus f of x divided by h. So in this case, f of x is equal to sine x, so f of x plus h would be sine x plus h. So therefore, lim when h tends to 0 would be sine x plus h minus sine x divided by h. And now that's why I wrote out what my identity was. This is my identity. So the limit when h tends to 0 would be sine x cos h plus sine h cos x minus sine x. The people who do further maths will know I'm getting quite confused right now because I keep thinking that's shine and cosh, but that's fine. Okay, let's keep going on. Let's factorize out what we can now. I know that there's a sine x common here and here, so let's go for it. The limit when h tends to 0 is, let's factorize out that sine x, and we're left with cos h minus 1 plus sine h cos x divided by h. Okay, let's keep going now. Now we are left with let's keep going. Lim h tends to 0. Now I was given some facts earlier. I was given that cos h minus 1 over h tends to 0. So this entire fact is basically sine x cos h minus 1 over h. This entire thing tends to 0. So sine x multiplied by 0 would be 0 anyway. So essentially you're just doing 0 plus sine h cos x over h. So therefore, we're also given the fact that sine h over h tends to 1. So therefore, essentially, it's just when the limit when h tends to 0 is that when cos x, and that's essentially just sine h over h. So therefore, this would tend to 1, so you are left with cos x. And therefore, the derivative of sine theta is cos theta. I did kind of change the x to theta. I wouldn't do that, but I don't think it would be that much of a problem if you did, but that's question. Okay, so question 12. Figure 5 shows a sketch of the cuboid OABCDGDF, DEF. Unit vectors I, J, and K lie on the following lines. Given that OA is 4i, and we're given some more details. The points M and N are the midpoints, okay? The point P lies on MN, so MN would be this line here, going in this direction. And the point P lies on the line on MN such that MP is equals to 3PN. Okay, so this is my point P. The ratio is 3:1, and MP is 3 times larger. So essentially, MP is just 3 over 4 times MN, and then PN is just 1 over 4 times MN. Therefore, the MP is 3 times larger. Show that OP is given by this vector. Okay, so the first thing that we can do is we know that P lies on the line MN, right? So the first sort of step that I'm taking naturally is find what is the vector form for MN. Now, how can I do that? I know that for part A, I know MN is essentially just the sum, or MO plus ON, which are just the positional vectors. So first step, let's find OM. So what is OM? OM would just be OA plus AM, OA plus AM. And I know that OA is 4i, and I know AM is just the midpoint of AB. AB is the same as OC, 3j, and therefore AM would just be 3 over 2j. There's my OM. Now let's do the same thing for ON. Now ON would just be O to N, so OC, which is 3j, and then C to N. So C to N would just be the same thing. C to G is the same as O to D. So therefore, this entire vector here is just 2k. So therefore, C to N, since it's the midpoint, would just be k. So therefore, ON is 3j plus k. Plus k. Okay, now let's keep going. Now that I have these two vectors, what's the next step that I can take? Okay, now I would form what my actual MN is, okay? So MN is MO, which is just the negative version of OM. So minus 4i minus 3 over 2j plus ON, which is 3j plus k. MN is therefore minus 4i plus 3 over 2j plus k. This is my MN. Now let's look back at the question. It wants us to find OP, right? So what I could do is I know that MP, is 3 over 4 of MN. And if I can write MP in different vectors, I could say that this is MO plus OP. So I know MP is 3 over 4 MN. So therefore I have MP. I already know MO from what we calculated over here to be minus 4i minus 3 over 2j. Then I can just rearrange to get my OP vector. So therefore I can easily solve for it. So MP is essentially 3 over 4 MN, which we got to be minus 4i plus 3 over 2j plus k. So this would simplify out to be minus 3i, as this and this would cancel, plus, oh wait, of course it wouldn't cancel for the whole thing, just for that bracket. So what's this minus? Was there a minus there? Yep. So that would be minus 3i plus 9 over 8j plus 3 over 4k. That is my MP. Now I have my MP, I know now let's just write that entire equation. So this is my MP. So therefore, MP is MO plus OP, and OP, which they want us to find, is just MP minus MO. And that is OP, which is going to be minus 3i plus 9 over 8j plus 3 over 4k minus MO, which is the negated version of this, because this is OM. So minus 4i minus 3 over 2j. Let's expand a little bit more. OP is going to be minus 3i plus 9 over 8j plus 3 over 4k plus 4i, negative, plus 3 over 2j. 4i minus 3i would just be I. 9 over 8 plus 3 over 2 would be 9 over 8 plus 12 over 8, is it? Times 4 times 4, yep. So that would form, what is that, 21 over 8? Yep. So I plus 21 over 8j plus 3 over 4k. And let's see, is that what they wanted us to get? I plus 21 over 8j plus 3 over 4k. So that's my answer for O. So part B is actually quite tricky. It says the straight line through OP. So okay, we had MN, right? This was our MN, and this was our sum point P. It says the straight line through OP meets the face BFGC at the point Q. Find the coordinates of Q. So there's a straight line at OP, and it meets the point Q somewhere. Let's say here. We have to find the coordinates of this. Now, what you really need to spot here is that when the point Q reaches that face, the j component will be turned into 3j. Now, why is that? Is because we start from the origin, and all of these points are 3j away. So if I ignore what, like, if there's x, y, z here, if there's x, y, z here, same goes for x, y, z here, and here x, y, z, regardless whatever x and y are, which will change, the y component will always be 3j, because there's a distance of 3j from here. For here, for example, it's 4i plus 3j. This is 2k plus 3j. So the y is always 3j. So therefore, the y component would be 3. Now, because it's a straight line, I know that, let's do the question now. OP was I plus 21 over 8j plus 3 over 4k. I know that this 21 over 8j, if it meets that face, will turn into 3j. So that's been scaled. So all we have to do is scale the remaining ones. So how would that work? We would do 21 over 8 times by something. 21 over 8x is equals to 3. So x is therefore equal to 3 times 8 divided by 21, which is just going to be 24 over 21, or 8 over 7. So therefore, you would just do 8 over 7 OP to give you the coordinates of OQ, and that will just be 8 over 7 times I plus 21 over 8j plus 3 over 4k, and this gives you an answer of 8 over 7i plus 21 over 8 times 8 over 7, yep, that will give you the 3, which you need, 3j, plus 24 over 28, which is same as saying 6 over 7. So therefore, my final answer would be 8 over 7, because I want to leave them as coordinates, 8 over 7, 3, and 6 over 7. And that is my answer for 12b, which was quite tricky. You needed to spot that if it reaches that back face, the j would turn into 3, and then scale it from there. Otherwise, a decent. Question 13 is a question on geometric sequences. Given that the first three terms of a geometric sequence are 8 sine theta, 3 sine 2 theta, and 2 plus 2 cos 2 theta, show that sine theta is equals to 8 over 9. So essentially what this question is telling us is that it's a geometric sequence. So what do I know about arithmetic sequences and geometric sequences? For arithmetic sequences, the difference is always the same between the terms, consecutive terms, and in a geometric sequence, the ratio is the same. So therefore, I want to find the value of sine theta, and the only thing I can really do here is set up some sort of an equation. So I could say that's 3 sine 2 theta divided by 8 sine theta. The ratio would be equal to the ratio of these two terms, which is 2 plus 2 cos 2 theta divided by 3 sine 2 theta. And now I just play around with this information to see if I can get sine theta 8 over 9. First thing I'm going to do, we have like terms, so I'm going to move them to one side and say 3 sine 2 theta squared is equals to 8 sine theta times that. So that would become 16 sine theta plus 16 sine theta cos 2 theta. Okay. Let's keep going now. The next step that I can really see is that sine 2 theta, let's express this. What can I change that to? Sine 2 theta would be 2 cos theta sine theta. This is the identity you should know. So this would become 6 sine theta cos theta. And that would be squared is equals to 16 sine theta plus 16 sine theta cos 2 theta. Let's keep going. I can take out a 16 sine theta common, actually. So I could say that 6 sine theta cos theta. I'm not going to square anything just yet. I'm going to do it once I get an opportunity to actually find something. So I could say that 16 sine theta common is going to give me 1 plus cos 2 theta. Okay, let's keep going now. I'm getting somewhere, I think. So I want to keep sine theta, right? I'm trying to keep sine theta. And I can see that cos is getting squared. So if I can somehow introduce a cos squared from here, I can get those cos squareds cancelled out. So let's keep going. 6 sine theta cos theta squared is equals to 16 sine theta. Now, what's the identity for cos 2 theta? You should know it's 1 plus, so cos 2 theta would be 2 cos squared theta minus 1. So 1 and 1 would cancel out. So you're essentially just left with 16 sine theta multiplied by 2 cos squared theta. Now let's fully expand. We'll get 36 sine squared theta cos squared theta is equals to 32 cos squared theta sine theta. Okay, so therefore, because we are trying to evaluate for sine, if I say, what am I trying to show? I'm trying to show that sine theta is equals to 1. So I'm going to cross out the cos squared thetas. And then I'm going to say that sine theta would go here as well, become 1. This sine theta would just become sine theta. So I'm going to say that 36 sine theta is equals to 32. And therefore sine theta is equals to 32 over 36. Sine theta is equals to 16 over 18, which is essentially 8 over 9. Which is my proof. Now, in this example, I am allowed to cross out the cos squared thetas. You are thinking that usually you can't do that because you miss out solutions. But in this case, we aren't trying to find any solutions. We're essentially trying to make a proof that the ratios would end up giving us this. But if it were that you have to find solutions, then you do have to account for cos theta solutions, of course. So in this case, it's fine to cancel out for part A, or you could just take it to the other side and you could show that if you factorize out sine theta and cos theta, you can bring it to 0. It's the same case. Part B says prove that the sum to infinity exists. For the sum to infinity to exist, the modulus of R must be less than 1. So you can just prove that what is the modulus of R is the ratio. So do 3 sine 2 theta divided by 8 sine theta. And essentially, you're just left with, this would be 6 sine theta cos theta divided by sine theta. So these cancel out. So you're left with 6 cos theta over 8. So this was, 8 sine theta. So you're left with 6 cos theta over 8. And you could do sine inverse of 8 over 9 to give me 1.0949. So just do 6 cos 1.0949 divided by 8 and you get your answer to be 0.344. Mod R is less than 1, hence your S to infinity does exist. Okay, next question is part C. Part C says find the value of sum of infinity minus sum of 10. Give your answer to 2 significant figures. Okay, so essentially, does it give us any more information? No. Okay, so my sum to infinity is going to be my A over 1 minus R, and my sum to 10 would be my A times 1 minus Rn, or in this case 10 terms, over 1 minus R. So these are just in your formula booklet. Okay, so we can actually start this question without having to actually find any values. So what it's essentially asking us to find is S infinity minus S10. So that is just A minus A 1 minus R to the power 10 divide by 1 minus R. It's the same denominator, right? So I could factorize out an A as well. And then I could say, what can I say? I can say A 1 minus 1. Wait, actually, let me make it, this would just make it confusing. So if I do factorize out an A, I'm left with 1 minus, and then you're left with a minus 1 here, and that is 1 minus R to the 10. So therefore, you're left with, divide by 1 minus R. So therefore, you have A 1 minus 1 plus R to the 10, divide by 1 minus R. So therefore, A, and that would just be R to the 10, divide by 1 minus r. Be careful here. The signs are a bit tricky. That's why even I got a bit confused there for a second. So just be careful with your signs there. Now let's keep proceeding forward. What is my a? My a is 8 sine theta. It's my first term. So therefore, my a is going to be 8 sine theta. Sine theta will be calculated as 8 over 9. So this would be 64 over 9. My r to the 10 would just be 0.344 or something, 0.344. Yep. So therefore, I would just do 64 over 9 times 0.344 to the power of 10 divided by 1 minus 0.344. And my answer, final answer, would be 0.0025, or in standard form, if I want to write it, it would be 2.5 times 10 to the minus 4. That's my answer for question number 13. Question 14 is a nice modeling question. It says the height of the tide H in a harbor is measured T hours after midnight. The rate of change is modeled by the differential equation, where A and B are constants. The largest value of the rate of change is 2. The time between consecutive tides in the harbor is 12. Maximum height of the tide is that. Find a complete equation for the model. So this isn't your standard trigonometric modeling, as it doesn't require you to use that formula for the sine and cos addition formula or anything like that. It's kind of tricky, actually, because you need to know the properties of the sine and cos functions. But let's still do it. Okay, so we have the first thing that is given to us is that the largest value of the rate of change is 2 meters per hour. So when we are at its maximum, dh over dt is equals to 2, and we also know that the maximum of the cos function bt of any cos function is going to be 1. So therefore 2 is equals to a times 1 to give me a value of a is equals to 2. So that's my first step done. So I've got up to the fact that dh over dt is equals to 2 cos times bt. Now let's keep going. Now it also says the time between consecutive tides of the maximum height in the harbor is 12 hours. So it's essentially saying that the period of the function is 12. But this is not talking about the rate of change, right? It's talking about the tides of maximum height. So I want something which would give me just h. So if I were to turn this equation from dh over dt into a h function, we would have to integrate, right? And that function would turn into sine. Cos integrates to positive sine. So this would be sine bt. Now, what is an important fact to know is that for any function, let's say sine at, the period of that function is 2 pi over a. It's just 2 pi over whatever the multiple it's being multiplied by. So in this case, so for example, normal function sine x, your a is essentially just 1, right? So your period is just 2 pi. So in this case, it's h sine bt, so therefore 2 pi over b, and we're given in the question that the maximum height in the harbor is 12 hours, the time between. So therefore my period would be written like this. So so essentially therefore my b is just going to be 2 pi over 12, and therefore it's pi over 6. So far I've got my model up to the fact that dh over dt is equals to 2 cos pi over 6 t. Let's keep going now. The last fact is that the maximum height of this tide in the harbor is 30 over pi meters. So now I need to integrate to actually get the height formula. So let's integrate. If I integrate, it would become h is equals to 2. What would be the thing? It would be 2 sine, cos integrates to sine, 2 sine pi over 6 t. And I like to also say that you have to divide by pi over 6. Okay, because if you're integrating, you divide. If you're differentiating, you times by. Okay, now let's keep going in this function. So let's actually do some rearrangement. So that's the same as saying h is equal to 2 divided by pi over 6, which is like 12 over pi. So therefore, it's 12 over pi times sine pi over 6t plus c. Don't forget your plus c's actually. dt plus c. Okay, now what does it say to us in the question? It says the maximum height of the tide in the harbour is 30 over pi. So the maximum, so when h is at its max, this is equals to 30 over pi. And I know that the sine function when it's at its max is at 1. So therefore, 30 over pi. So when h is 30 over pi, it would be 12 over pi times the max of the sine function, which would essentially just be 1. So times that by 1 plus c. So therefore, my c is 30 over pi minus 12 over pi to give me c, and c is 18 over pi. And if I write my final model, which they want, h in terms of t, it would be h is equals to 12 over pi sine pi over 6t plus 18 over pi. That should be my final answer, and yeah, it is. That's fine, and that's question number 4. Question 15 is another modeling question. You can clearly see that Edexcel are moving so heavily towards these modeling type questions, but I don't think this one is too difficult, or at least the start isn't too bad. Okay. So part A says question 15A. The number of mice in an island is being monitored. When monitoring began, there were 4,000 mice. So this is when t is equals to 0. In a simple model, the number of mice is modeled by this equation in thousands, where k is a constant and t is the number of years. Find a complete equation. Okay, so x is the number of mice in thousands. So if it's in thousands, therefore, x would equal 4, because it's 4,000. So 4 is equals to some k, and this is the value when t is equals to 0 at the start. So 0 plus 2 divided by 0 plus 5, 4 is equals to 2k over 5, 20 equal to 2k, k is equals to 10. So therefore my model is just going to be x is equals to 10 times 3t plus 2 divided by 4t plus 5. There we go. Now, what's part B saying? Hence calculate the long-term population predicted by the model. So long-term, just put t to be very, very large. I'm just going to write it to be, let's say, 100,000. 100,000. And just shove that into your calculator. Just do 10 times 3, 100,000 plus 2 divided by 4 times 100,000 plus 5. Make sure that if you're using 100,000, they're both the same at the numerator and denominator, and you should get something like 7.499. So it's tending to 7.5. It's in thousands, so therefore long-term population is equals to 7,500. Okay, because you just times that by 1,000. Okay, let's go on to the next part now. That's part B done. Okay, part C of this question says, in the second model, the number of mice x is modeled by the differential equation, where t is the number of years after monitoring began. Write 4 over 6x minus x squared in partial fraction form. Okay, 4 over 6x minus x squared. You have to write this in partial fraction form. So first, let's get an x out. I'll get 6x, oh sorry, not 6x, 6 minus x. And now I want to split this into its relative parts, so that would be a over x plus b over 6 minus x. So 4 is therefore equals to 6 minus x times a plus bx. Okay, so when x equals 0, 4 is equals to 6a, a is equals to 2 over 3. When x is equals to 6, 4 is equals to 6b. So therefore, b is also 2 over 3. So they're both 2 over 3. Both of them are 2 over 3. Okay, so now let's keep going. Is that part C done? Oh yeah, they just wanted us to write it in partial fraction form, isn't it? So therefore, we can write that as 4 over 6x minus x squared to equal 2 over 3x plus 2 over 3 times 6 minus x. So I'm not going to go too much deeper into it. I'm just going to leave it like that. So that is my answer. Okay, in part D of this question, it just wants us to solve the differential equation with the given initial condition to show that x is equals to some expression in E. I'm not going to go too much into the expression. Let's solve it and see if we can get it to be something like that. And the initial condition is that when t is 0, we have 4,000 mice. Okay, so let's do part D. My differential equation was 4 dx over dt so for 4 dx is equals to 4 dx over dt, is it? Yeah. Over dt is equals to 6x minus x squared. Okay, so let's start solving. So I can say 4 divided by 6x minus x squared dx is equals to dt, simply treating it like a fraction. Let's integrate both sides. So this is why they made you split the fraction into partial fractions, so you can integrate it. Otherwise, it would just be too long, maybe in one step. So therefore, we want to do the integral of 2 divided by 3x plus 2 over 3 6 minus x is equals to t plus c. So dx t plus c, because integral of just 1 dt would just be t plus c, right? Now let's actually do the integration of the left hand side. So this would just become, this is the same as doing 2 over 3 integral 1 over x, right? And the integral of 1 over x is just ln x. So this would become 2 over 3 ln x, but this second part is doing 2 over 3 times the integral of 1 minus 6 over x. So that would become, if I just said that becomes ln 6 minus x, then if I redifferentiated that again, that would be 1 divided by 6 minus x times minus 1. So I have to divide by a minus 1 as well. So if I do divide by a minus 1, it's essentially just changes this plus into a minus. So that would become minus 2 over 3 ln 6 minus x, which is equals to t plus c. So that is the answer so far up till there. I'm just checking if all my working is correct up till here. It should be fine. Yeah, that's fine. Now we can use the initial condition that it stated. It said when t is equals to 0, there are 4,000 mice measured in thousands. So therefore, I can say t is equals to 0, x is equals to 4, because it's 4,000. So therefore, 2 over 3 ln 4 minus 2 over 3 ln 2, because it's 6 minus 4, is equals to t, which is 0 at this time, because when initially there was 4,000 mice, so time is 0. So therefore 0 plus c is just c. So therefore I can work this out. So this can be split into a more, I can say this is 2 over 3. Taken out ln 4 minus ln 2, which is just, actually this is just going to be 2 over 3 lns. When they minus, they divide. So therefore 4 divided by 2 would just be 2. Okay, so my c is therefore 2 over 3 ln 2. Now I'm just going to make this a bit smaller so I can regather. So 2 over 3 ln 2 is my c. Let's rewrite my model. So it says 2 over 3 ln x minus 2 over 3 ln 6 minus x is equals to t plus 2 over 3 ln 2. Now the next step that I can do is I can join these two lns, because I'm still a far way away from the actual answer. It wants my answers completely in ease, but I can see how they might get there. It's all about converting, right? So let's do that. So if I take out a 2 over 3 common, I can say ln x minus ln 6 minus x is equals to t plus 2 over 3 ln 2. Therefore, I could say 2 over 3 ln, and then brackets, x over 6 minus x is equals to t plus 2 over 3 ln 2. Does it want it in what? What does it want us to make it the subject? It wants us to make x the subject. So the x's are actually in the bracket. Okay, so let's keep going now. Now I can, what more can I do? I can join these 2 over 3s from the other side as well. I could say this is ln x over 6 minus x, which is equal minus 2 over 3 ln 2 is equals to t. Let me just make this a little bit smaller again. Wait, let me just... Okay, so therefore this would become 2 over 3 ln, we take out x over 6, 2 over 3 common, sorry. So 2 over 3, you take out the ln, this would become x over 6 minus x minus ln 2. So therefore you just do the same thing, right? 2 over 3, you just divide that by 2, or that would essentially just become 2 over 3 ln x 2 times 6 minus x in the denominator is equals to t. So now I've got it in terms of t. Now it's all about converting that into x's. So therefore I know ln x 2 times 6 minus x is equals to 3 over 2t. Let's move the t to the other side. Now I can raise that to the power of e. So I can say x times 2, 6 minus x, is equals to e to the power 3 over 2t. Time to make it smaller again. Oh, makes it smaller. E to the power 3 over t. Now let's keep going. So x is equals to, therefore, e to the power 3 over 2t times by 12 minus 2x. Let's expand that out and see what we get. X is equals to 12e to the 3 over 2t minus 2e 3 over 2t x. Now we can go up to the other side. Say x plus 2e to the power 3 over 2t x is equals to 12e 3 over 2t. Take out an x common, we get 1 plus 2e 3 over 2t to give me 12e 3 over 2t, and therefore my final answer would be x is equals to 12e 3 over 2t divided by 1 plus 2e 3 over 2t. So quite a gruesome question in the end. It does really stretch you. Is that what they wanted? 12e to 3 over 2t over 1 plus 2e to 3 over 2t? Yep, that is my final answer, and that was quite gruesome towards the end. But if you persist and make sure you don't make any mistakes in your calculations, keep checking them readily, you should not be too bad. It shouldn't be too bad. Hence, find the long-term population of mice predicted by the second model. Same principle applies. Just make t as large as possible. So if I make t 10,000, so if I just do 12e 3 over 2 times 10,000 divided by 1 plus 2e 3 over 2 times 10,000, I should get an answer up on the calculator to be 6,000. Okay, or rounding off, it would be 6,000. So that is my answer for question number 15. Quite a long part D, but otherwise, overall, it's a challenging question. Question number 16, the final question on this paper. It's a standard parametric equations question, so if you've done enough practice on these, you should be fine with this. So 16a says the point P for k, where k is a negative constant, lies on the curve, and we're given some parametric equations, and we want to find the exact value of k. So I'm given the value of x, and I'm given the parametric equation. So I could say that x is equals to 2 plus 4 cos t. So therefore, x when it's 4 is equals to 2 plus 4 cos t. We can solve for the value of t. We get to the point where we get cos t is equals to 4 minus 2 over 4, which is a half. And therefore, t in the required range between this would be t to give me, on the calculator, you would use your graphs or unit circle to check, and you should get t to equal minus pi over 3. Now, same principle, you just sub this back into the y. So just say y is equals to 3 times minus pi over 3 plus 2 sine minus pi over 3. And you get your answer of y to be minus pi minus root 3. That's my answer for the part, is that part A? Yeah, part A. So y is minus pi minus root 3. And yeah, now let's move on to B. B says the point Q lies on the curve. Given that the gradient of the curve at Q is minus 3 over 2, find the value of T at Q, giving your answer to 3 significant figures. Okay, so we're given X and we're given Y. So whenever we want to find the gradient using parametric equations, we can combine these two. How would I do that? I would say for part B, dy over dx, the derivative, is the same as dy over dt divided by, or times by actually, I'll just write it directly, times by dt over dx. So essentially dt over dx is just 1 over dx over dt. Okay, so dy over dx, because, and if I want to double check, you can see the dt's would cancel out, essentially, if we're treating them as fractions, and you would get dy over dx. So let's try that now. So I know x is equals to 2 plus 4 cos t. And I know y is equals to 3t plus 2 sine t. 3t plus 2 sine t. So let's differentiate both of the x and y with respect to t. So let's do x first. Dx divided by dt, I would get, cos differentiates to minus sine, so you would get minus 4 sine t. And dy divided by dt over dt would just be 3 plus sine differentiates to cos, so 3 plus 2 cos t. So the derivative dy over dx is essentially just going to be 3 plus 2 cos t times by 1 over of this, so it's just dividing by minus 4 sine t, which is given to me in the question to equal minus 3 over 2. So therefore, I know the answer would be minus 3 over 2. Okay, let's keep going and see where we can get up to. Okay, so I'm going to move the minus 4 sine t to the other side. I'll get 3 plus 2 cos t is equals to 6 sine t. Therefore, 3 is equals to 6 sine t minus 2 cos t. Okay, now this is sort of the, I guess, the unique selling point of this question. You know, Edexcel, they do like to blend different types of questions. Now, in this case, what they're doing is that the stronger applicants will be able to identify, stronger sitters of this exam would be able to identify that this is the form for your r sine t minus alpha. So in this case, this is using the trig identity. Like how I mentioned before in question, what was it, 14 or 13? Over here, I had a suspicion that they didn't make me use my sine addition formula. So I thought maybe there are somewhere else, and they've blended it with parametric equations, which is quite unique. I haven't seen that before. Okay, so now let's keep going further. So now that I know it's blended out, I can say that 6 sine t minus 2 cos t is equals to r sine t minus alpha. Therefore, I can say that I know the addition formula to be 6 sine t minus 2 cos t is equals to r sine t cos alpha minus r cos t sine alpha. Okay? So therefore, I could say that my my r sine t is equals to 6. My r cos alpha, sorry, not sine t. R cos alpha is equals to 6. And my 2 cos t is equals to r cos t. So therefore, my r sine alpha is equals to 2. So therefore, I could say, now to find the value of r in itself, you would just do Pythagoras with this too. So r is essentially just going to be the square root of 6 squared plus 2 squared to give me root 40. And my angle would just be r sine alpha divided by r cos alpha to give me tan alpha, which is 2 over 6 or 1 over 3. So alpha would be, when you do the inverse in degrees, it would be 18.4, or in radians, it is 0.322. So that is my value of alpha. Now that I have my value of alpha, I can write out my entire model. So I can just write 6 sine t minus 2 cos t to equal root 40 sine t minus 0.322. Now I wrote earlier that 6 sine t minus 2 cos t is equals to 3. So I can just say this is equals to 3. I could say sine t minus 0.322 is just 3 over root 40. Therefore, t would be sine inverse 3 over root 40 plus 0.322, and t comes out to be approximately 0.816. And as it told us to leave it to some 3 significant figures. So my value of t at q is 0.816. So that was a pretty challenging question as well, because it sort of blends different techniques or different topics in maths. But other than that, if you do know the spec well, you can definitely answer them. And that is the end of this paper. This is the final answer. Yep, that's the end of this paper. Thank you for watching, and yeah, stay tuned for more videos. Soon I'll be doing some more A-level papers for maths, more practice, and that should be helpful. Thanks.